Welcome to the DIY Honda Garage channel. The DTC P16E2, indicating a PGM-FI, Program Fuel Injection, ACG, Alternating Current Generator, LIN, Local Interconnect Network, Communication Error, is a critical issue that can affect the performance of the Honda CRV from 2017 to 2022. This error typically arises when there is a problem with communication between the alternator and other components in the vehicle's electrical system. The alternator, crucial in charging the battery and powering electrical systems, can be found mounted on the engine block. The LIN protocol is used for streamlined communication between different electronic control units, ECUs, within the vehicle. A communication error can indicate issues such as poor connections, loose terminals, or faults in wiring. Correctly diagnosing and repairing this error is essential for maintaining the vehicle's reliability and performance. This guide provides in-depth troubleshooting procedures to accurately identify and resolve this DTC. DTC P16E2 points to a malfunction in the PGM-FI system, specifically in the communication with the ACG. The PGM-FI system controls fuel injection and engine performance, while the ACG, or alternator, is responsible for converting mechanical energy into electrical energy to charge the battery. The alternator is typically located near the engine's front and may have connections with other vital components like the powertrain control module, PCM, and the battery sensor. The PCM acts as the brain of the vehicle, coordinating functions of various components, including the alternator. This error can disrupt the communication channel through the LIN network, leading to incorrect readings and ultimately affecting engine performance. It is critical to inspect the aforementioned components to ensure proper functionality and diagnose the issue accurately. Several potential causes contribute to DTC P16E2. Starting with loose terminal connections on the alternator's causative +B terminal. Such a loose connection can interrupt the communication signal essential for normal operation. Additionally, there could be wiring issues, such as shorts or opens within the local interconnect network, LIN circuit. The alternator itself might also be faulty, failing to communicate effectively with the PCM and other associated components. Furthermore, problems with the battery sensor can complicate the electrical system's performance, as this sensor plays a crucial role in monitoring voltage and overall battery health. Being aware of these possible causes allows for a targeted approach during troubleshooting and repairs. The symptoms of DTC P16E2 predominantly include the illumination of the engine warning light on the dashboard. This occurs as a direct indication of a malfunction within the engine systems. Drivers may also experience various electrical system failures, as the integrity of the vehicle's power and communication systems is compromised. One common indicator is poor battery performance, leading to frequent battery charging issues, which can leave the vehicle unable to start or may cause flickering lights. Additionally, increased fuel consumption could be observed, resulting from the engine's inefficient performance due to disrupted signals between the alternator and the PCM. All these symptoms underscore the need for timely diagnosis and remediation to ensure optimal vehicle operation. The first step in troubleshooting DTC P16E2 is to verify the existence of the problem. Begin by turning the vehicle to the on mode without starting the engine. Next, utilize the HDS Honda Diagnostic System to clear any stored diagnostic trouble codes. After clearing the codes, it is essential to turn the vehicle off to the lock position and then return it to the on position after waiting for 10 seconds. This procedure ensures that the system has an opportunity to reset and recalibrate before rechecking for any pending or confirmed DTCs. If DTC P16E2 reappears during this check, it indicates the problem is persistent and requires further investigation. During the second troubleshooting step, check again for any pending or confirmed DTCs using the HDS. Particularly, confirm if DTC P16E2 indicates a PGM-FI battery sensor LIN communication error. If DTC P16E2 is present, proceed directly to Step 4 outlined in the troubleshooting protocol. If not, move to Step 3. This step is crucial, as identifying additional DTCs can help in narrowing down the possible failure areas within the communication network of the vehicle. Recognizing whether multiple DTCs are reported can also aid in addressing related issues simultaneously. In the third troubleshooting step, verify if DTC P16E2 indicating a PGM-FI shutter grille LIN communication error is present. This requires checking for pending or confirmed DTCs once again with the HDS. If DTC P16E2 is confirmed, you will proceed to Step 8 in the repair protocol. If it is not present, continue to Step 12. Assessing this additional DTC helps to further isolate the problem and provides insight into whether multiple systems are involved in the communication disruption, which could point to more extensive issues within the vehicle's electrical architecture. Now the focus shifts to diagnosing connectivity issues within the LIN communication system. Start this troubleshooting step by turning the vehicle to the off-lock mode before disconnecting the alternator 1P connector. Once this connector is removed, you need to check for continuity between specific test points. The alternator 1P connector's female terminal, number 1, and the body ground. This will determine if the wiring is intact and free from faults. The test conditions require the vehicle to be in the off mode to ensure that no power is running through the circuits during your checks. A continuity test serves as a reliable method to assess the functionality of wiring and connectors involved in the communication network. In this fifth troubleshooting step, the procedure involves jumping the SCS Security Communication System line with the HDS and allowing over a minute before rechecking continuity. This is crucial for reducing false signals caused by transient faults. Continuity testing must then be performed between the alternator 1P connector terminal and body ground. One must disconnect several connectors, one at a time, including the PCM connector B, 51P, and various shutter grille connectors. Is at any point the continuity signal ceases while disconnecting one of these connectors, it indicates that the LIN wire is functioning correctly. However, should the continuity remain, further investigation into the LIN circuit's integrity is mandated to identify and rectify short circuits effectively. The sixth step of troubleshooting requires you to reconnect the alternator 1P connector and then disconnect the 12-volt battery sensor 2P connector. It is essential to check for continuity between the battery sensor connector's terminal and the body ground while the vehicle is in the off-lock mode. Again, this will help verify if the necessary wiring is functional and not damaged. If continuity is confirmed, the alternator is likely faulty, and replacement will be necessary to restore normal operation. If there is no continuity, the diagnostics will proceed to the next troubleshooting step to evaluate additional components. In the seventh step, you will again jump the SCS line using the HDS and wait more than a minute to stabilize connections. After that, disconnect the alternator 1P and PCM connector B, 51P, as part of the test protocol. You will check for continuity between the alternator 1P connector's female terminal, number 1, and PCM connector B, 51P terminal number 40. If continuity is present, this indicates that the LIN wiring is intact, allowing the diagnosis to focus on other potential issues or continue evaluation of the PCM for potential replacement. If continuity is absent, it indicates a likely open circuit in the LIN wire and requires repair of the wiring between the alternator and PCM. Step 8 pertains to verifying continuity within the LIN communication pathway while the vehicle is set to off, lock. You will disconnect the alternator 1P connector and measure continuity between its terminal number 1 and body ground. This step is crucial to diagnose potential failures not previously identified. If continuity is confirmed, proceed to step 9 for further tests on the LIN wire integrity. If there is no continuity, step 10 should be initiated to explore deeper faults beyond the alternator that might affect LIN communication. In this 9th troubleshooting step, the objective is to assess the LIN wire between the alternator and the body ground. Begin by jumping the SCS line using the HDS and waiting over a minute. Afterward, disconnect several connectors while checking for continuity between the alternator 1P connector and body ground. If at any moment the continuity is lost, it indicates that the LIN wire is functioning properly and allows for identification of the specific part causing communication failures. If there is no change in continuity, the focus must shift to repairing any shorts in the LIN wire running between the PCM, alternator, battery sensor, and shutter grille to restore the communication integrity. For the 10th troubleshooting step, begin by reconnecting the alternator 1P connector. You will then disconnect both upper and lower shutter grille 4P connectors one at a time. This testing measures continuity from the shutter grille terminals to body ground, while the vehicle is set to off lock mode. This procedure is critical for diagnosing potential shorts or opens in communication paths. If continuity is confirmed, the next step is to replace the alternator. Conversely, if continuity is absent, the inspection must shift towards the next steps in the diagnostics to locate any additional wiring errors. The 11th troubleshooting step revisits the procedure of jumping the SCS line with the HDS, waiting over a minute before conducting continuity checks. Disconnect the alternator 1P and PCM connector B, 51P, for this phase of the testing. With both connectors removed, conduct a continuity test between the alternator's terminal number 1 and the PCM's terminal number 40. A positive continuity reading indicates the LIN wiring is intact, leading to the conclusion that either the PCM requires a replacement or further diagnostics are needed. If continuity is absent, it suggests an open circuit needing repairs in the LIN wire between the PCM and the alternator. In the 12th and final troubleshooting step for DTC P16E2, the initial action involves turning the vehicle to the off lock mode and employing the HDS to jump the SCS line. As before, you must wait for more than a minute to ensure stability in the system. Following this, disconnect the alternator 1P and PCM connector B, 51P, to perform a final continuity test between the alternator's female terminal number 1 and PCM connector B's number 40. If this test shows continuity, it affirms that the LIN wiring remains functional. However, if there is no continuity, the diagnosis directs focus on repairing the open circuit in the LIN wire running between the PCM and the alternator, ensuring that the communication channel is restored and functioning effectively. Upon completing the troubleshooting steps for DTC P16E2, it's crucial to verify that all repairs have effectively resolved the issue. Start by clearing all DTCs using the HDS, ensuring that any error codes regarding the PGM-FI or the LIN communication error are removed. After clearing, take the vehicle for a test drive to evaluate its operational performance under various conditions. During this drive, closely monitor for any signs of the DTC reappearing. particularly the engine warning light or other related symptoms. If the error does not return, it confirms the success of your repair efforts. It's essential, however, to document all findings and actions taken to provide a comprehensive record for future reference. To prevent the recurrence of DTC P16E2 and ensure continued reliability, implementing a regimen of preventive maintenance is vital. Regular inspections of electrical connections, particularly those on the alternator and the PCM, can help identify any loosening or corrosion before they lead to failure. Additionally, performing routine checks of the battery, including its health and voltage levels, will help maintain the overall electrical system's integrity. Utilizing high-quality wiring and components also decreases the likelihood of communication errors arising from wear or degradation. Lastly, using a systematic approach to troubleshooting when errors do occur can help in rapidly diagnosing and resolving issues, thus extending the lifespan of the vehicle's electrical components. In conclusion, understanding DTC P16E2 is essential for maintaining the Honda CR-V's performance from 2017 to 2022. Early identification of symptoms like the engine warning light and electrical system failures can lead to a quicker resolution of underlying issues. Following a structured troubleshooting approach allows for systematic identification and repair of faults, ensuring that communication within the LIN network remains functional. A critical aspect is ensuring the integrity of connections between components such as the alternator, battery sensor, and PCM, as these are foundational to the proper operation of the vehicle systems. By applying thorough diagnostic methods and preventive measures, you can significantly enhance the reliability and functionality of your Honda CR-V. Please like and subscribe to the channel. See you next time.